I took the machine learning specialty exam. Hi, everybody. Wow, it's been a crazy day today. I literally just took the machine learning specialty exam. It's been a year and a half in the making. I've been learning and playing around with concepts and using my Jupyter notebooks and trying to figure out this stuff, trying to figure out the math behind it. You know, it's been a whole confusion matrix all the way. I'm going to do a bit of an overview of what this exam was like. And then a future video is going to talk about how I prepared for this exam, what resources I was using, and what the approaches that you should be also looking at are for passing this exam. Now, let me first say one thing. If you are not in the machine learning field yet, you're looking to get into the machine learning field, start working with machine learning. You will need hands-on experience with machine learning to be able to understand these concepts. There is no reason for you to, jump out of infrastructure or developing or whatever into machine learning just to have this exam. If you're not going to be working with machine learning, if you don't feel like, if you haven't worked with big data up until now and you're just looking, machine learning being a cool new thing to pick up, don't bother. Okay? Honestly, I'm going to say I have the least experience in machine learning from my work, from my past experience. I have some experience with big data. I have some experience with SQL. I have some experience with addressing data and trying to analyze it. Machine learning is an extension to that. It's an extension to data analytics. It's an extension to statistics, an extension to trying to understand your data, right? Trying to get some kind of end result out of your data. Now, if you're intent on taking this exam, I say have enough experience with AWS where you understand the underlying platforms. So basically the underlying platforms will be anything covered in the architecting or SIS Ops or developing associate tier. Any of the associate tiers will cover the platforms that you need to understand. There's a lot of emphasis on S3. There is a lot of emphasis on delivering data. For example, Kinesis is a definitely a factor here because we're talking about just anytime there's real-time analytics required, it's always going to be an option. Understanding of how to use Lambda, how to invoke it, definitely a requirement. And then EC2 is a definite requirement because you need to understand the EC2 features, the VPCs, the VPC security, and how it relates to other services. For example, VPC endpoints, how you can access data through a VPC endpoint for S3, right? And of course, then SageMaker is going to be your primary tool that you're going to be working the actual machine learning deployments on. Understand the built-in algorithms and understand how to customize your algorithms. Now, let's go back and let's take a look at what this is all about. All right, 1 to 2 years experience developing, architecting, running ML deep learning workloads on the AWS cloud. So developing or architecting or running. That's SIS Ops is running, the developer is developing, and architecting is solutions architect, right? So definitely the associate tier plus then this. Yeah, the ML part is the one that's going to be the biggest challenge if you're not familiar with machine learning, because you need to learn all the basics, right? So we're talking about the ability to express intuition behind basic ML algorithms, right? What they want you to do is be able to understand how ML algorithms work. There's, over 200 different features that SageMaker has. They're not going to quiz you on each and every algorithm that's in there. They're just going to quiz you on the most commonly used one. And that breaks down into a few, maybe like 10, 15 algorithms that are sort of the most commonly used ones that you should be pretty comfortable with for this exam. Experience with basic hyperparameter optimization, right? So hyperparameter optimization, why we do it, and after we've done it, if it still doesn't deliver our results, how do we optimize the model even further after we know that we've hit the best hyperparameter optimization set. Deep learning frameworks. There's going to be a bit of insight into deep learning frameworks. Definitely. Best practices. So always look at security, always look at optimizing models for performance. Know which models can be trained on GPUs and which models can be trained on CPUs. And also, just choosing the optimal model to use for a certain task. And then deployment and operational best practices. This is just running and securing and how to connect your VPC to the SageMaker and how to connect SageMaker to an S3 endpoint and things like that. So let's look at the exam guide itself. So again, exam guide itself just reiterates what we saw on the website, right? Classic AWS multiple choice, multiple response. And of course, you're going to have to get a score between 100 and a score of 750 to pass, right? So just like all the other specialty, 750 is your passing score. Domains, data engineering. Basically, when we talk about data engineering is where to store the data and how to feed it to machine learning, how to store your test validation and production data. Look at data ingestion. How do we ingest data? Are we just going to store it on S3? Are we going to feed it through Kinesis? Are we going to, feed an EMR model that we have developed for that? Also, where does Glue fit into the ingestion part, and how you can use Glue to do basic data transformation, how you can use Kinesis Firehoses built-in features. So for example, if you've got JSON text coming in, how to transform it into Parquet, Firehose is the best option. And then what do you do with CSV data? And you need to transform it into Parquet. Again, probably here you're going to use Glue, because Glue's going to be able to convert CSV to Parquet, because natively Firehose doesn't do CSV to Parquet. Additional data transformation solutions would be something like where you've got IoT. IoT can run some data transformation. So it's kind of connected also a bit to IoT here, because there's going to be questions about a particular system sending you metrics or data and how to efficiently store and process that data. If it's a question with MQTT inside, if they're asking you about the MQTT protocol, always know that the IoT is the only one that's going to be handling MQTT. Domain 2, exploratory data analysis, preparing data, right? How do you sanitize it? How do you choose the right categories? So for example, if you've got data that that has surplus information, like for example, you're selling ice cream, right? And you want to predict where and when to send the ice cream, right? Do you need the sales data for your company during the winter months? You probably don't, right? Because you're not selling ice cream. Or perhaps you are. You got a year's round ice cream production, whatever that means. I don't know. Also, missing data. How to input missing data. Are you going to just do it with mean substitution where you're just going to substitute mean values or median values, or are you going to go with just deleting the data that doesn't have values if it's not important? Sometimes you got missing data and you're like, can't use that in my data set. Sometimes there's going to be correlation, and you're going to see that there's correlation in other data. So you could, from correlated data, you could actually create missing data. And especially if that's a larger amount of data that's missing, like for example, you're missing 25% of your data. Just feeding the median would, probably bring a lot of bias towards the median. So what you want to do is you want to, try to reconstruct that data. How to do that? Feature engineering, how to do principal component analysis, how to understand which features should be used in your training model and which features are giving you problems. Which features are, going to give you outliers, and how to normalize your data, how to make sure you rationalize data before feeding it to the model. And then analytics and visualization, right? So what kind of analytics and visualization can you use to quickly figure out whether the data is going to perform well, or figure out which hyperparameters have been tuned properly, figure out a lot of information, like can you find any grouping in the data, and which types of graphs, which types of visualization are going to be good for that. Then modeling. This is the one that I struggled with modeling a lot. Like I can tell you that for the first few months, I just didn't understand it at all. I basically had zero understanding of what modeling means. And it took me months to just understand how parameters and hyperparameters and how these neural networks and all these different machine learning models actually work and what they do. And essentially, once you understand that, it's all about figuring out hidden meaning, right? We have a big, huge data set. Our data set represents something when we look at it, but then we want to extract some hidden meaning from that data, how it correlates, how different features of that data correlate with different data points in the data set. That's essentially what you need to know. Now, all you need to understand is to find different types of hidden data in different types of data sets. You need to use different models and different algorithms, right? So selecting the appropriate model is going to be definitely a big part, right? Modeling is sort of the biggest part here. Training machine learning models, training and performing hyperparameter optimization and how many layers you need, that's going to be a crucial factor. You might have questions that will show you an outcome of a training process, and then they'll ask you, what's the best solution to optimize this training, and you'll just be presented with a graph, and they'll give you like, what do you need to do here? So which approach will give you the best results, right? And then you see, for example, test data and validation data being very close together at some point, and then diverging and converging and diverging again. What's the best solution, right? Again, that's something you need to learn here. I'm not going to give you answers. I don't want to give you answers. I don't want to give you questions or answers. I just want to show you sort of I'm going to show you where to look in the next video. I'm just going to do this one today just to vent my frustration with how difficult this exam was for me personally. Others will say it was easy for them. Yeah, I believe you. I just had a comment up on one of my videos saying, oh, I think advanced networking was much more difficult than machine learning. Well, not for me. For me, advanced networking was, easy peasy, basically. Because I come from the infrastructure side, and a lot of my years of experience were with infrastructure, with virtualization, with hypervisors, with tuning hypervisors, network connectivity in hypervisors, storage connectivity. And then after spending a better part of the decade in hypervisors and virtualization, I went into cloud and started sort of working on DevOps project and picking up a little bit of coding and picking up a little bit of scripting and picking up a little bit of big data and processing logs and SQL and analytics and all bits and everything sort of starts fitting together when you're in cloud. And when you're picking up all of these things here and there, that generalizing your knowledge is really, really useful right now in cloud. If you have generalized knowledge, just like a machine learning model needs to be generalized, your knowledge should be generalized. Anyway, evaluating machine learning models. How do we evaluate area under the curve and things like that? Machine learning implementations, then it's the SIS Ops part, right? Then it's how to build your highly available, highly scalable, highly performant, fault-tolerant machine learning environments. This is SIS Ops stuff. This is solutions architecting stuff. This is not even so much developing stuff. This is more like this is basically taken out of, this is where it's from, right? SIS Ops. SIS Ops. This is where it's from. Check out my books. Support this channel by clicking the links in the description instead of watching commercials. I want to give you stuff that's important for you. It's got to be relevant to certification. It's got to be relevant to cloud. It's like if AWS has a commercial on it here for some new service, then I'll put it on. Or Google Cloud comes and says, here, Marco, here's some stuff. Then I'll put the commercial on. I want it to be relevant for you. I want it to be something that you can actually use in your life. I don't want you to be, I'm not going to do a review of Lit Mobile's new battery, which I'm being bombarded. I'm not going to do a review of, and excuse my French, fucking Asana, which constantly is popping up on my feed. I use Asana because it's... Go fuck yourself. Go use Asana and go fuck yourself. Lit Mobile, you can go fuck yourself. Whatever you are. The amount of commercials I get for Lit Mobile is insane. Why do they think I need a battery pack? I'll show you a battery pack. I'll be right back. That's a battery pack there, right? This is... actually works, right? You can see the lights. This was probably like $10. It has 2 lithium-ion batteries. It's got 6,000 milliamp hours, and I measured it to about 4,500 is actually usable out of this. And what I do with this thing is, this is pretty ingenious. So what I did is, as you can see, is I screwed a little bit of a nice screw here, and I've got a couple of nuts here. And what I do is I put my... Where's my camera? I sometimes put my little camera and I attach it to this thing. Woo! And then I take a USB cable, right? And when I feel like walking and talking a lot, I want to always have extra power. And now, voila, extra power. And this is charging my thing, right? And this thing is charging, red light. And this has got a 1,000 milliamp battery. This is like 4,500 milliamps of usable capacity. I can recharge this thing a couple of times potentially, right? So I can get like probably, I don't even know how many hours, but I probably can get 3 or 4 hours out of this guy, plus whatever is on the internal battery. So yeah, that's FU Lit Mobile. And you can see this has been used and abused and is all glued up with glue, and it still works, and it costs $10, and it's 6,000 milliamps. I don't know what happened, but somewhere these things became popular, and because they became popular, their prices increased for some reason. The cost of a 18650 battery is, a few dollars. And if you put two 18650 batteries and a little bit of a logic board, and a USB port, and then Marco screws a big old long screw and puts a couple of nuts on it so that he can have his camera there, right? If you just put a little logic board and two batteries in there, this thing shouldn't cost more than $20. And they're telling me, oh, we got a 10,000 amp hour. Yeah, good for you. 10,000 amp hour. One more battery right here. You get, about 7,500, and then one more battery here. And that's like 10,000 usable capacity. That shouldn't cost more than $50. Even if with all the margins and everything. Anyway, rant over. Okay, SIS Ops, architecting, implementing appropriate machine learning services and features. Here we go, services and features. Recognition, comprehend. What else? How to use transcribe, how to use translate, how to use all of those features and what they apply for. A lot of the times, also here, machine learning, the deep AR solution, right, also maybe is in the same aspect. Security best practices, that's just security best practices, policies and roles and keeping data off the internet. And then deploy and operationalize machine learning solutions. We're talking about SageMaker endpoints and how to deploy models onto your endpoints and how to do blue-green deployments on SageMaker. How to use SageMaker on your own laptop, right? Pulling the container down and using it on your own laptop. What else? Like all kinds of different cool stuff that you need to know here. And yeah, here's some example questions. A machine learning team has several CSV datasets in S3. Historically, models built with the SageMaker linear learner algorithm have taken hours to train on similar sized datasets. The team's leaders need to accelerate the training process. What can a machine learning specialist do to address this concern? A. Use SageMaker pipe mode. B. Use machine learning to train the models. C. Use Kinesis to stream the data to SageMaker. D. Use Glue to transform the CSV dataset to JSON format. Right? We have large datasets in S3. Models built with the SageMaker linear learner have taken hours to train on similar sized datasets. How do we speed up this one? I'm not going to give you the answer here because we're just looking at possible questions. I don't want to break this for you, right? Use these to test your knowledge. I'm just giving you examples what the questions are like. And yeah, that is it. Don't forget to subscribe to my channel if you're new here. There's a lot of cool stuff that's going to be happening. There's still a contest out, so make sure to take a look at the link where I will put my 100 subscriber contest link in the description. So yeah, that's it. Thank you very much for watching. That's where I'm going to leave it today. Bye.